Hi, Physics, Mr. Janowski. This is Chapter 13, Homework 1, Problem 7. So, what is the gravitational attraction between the Sun and the Earth and between the Sun and Mars? So, we're looking for two different things here. So, red pen, step, huh? All right, so for the first part, part A, we could call it, I could have numbered it this way F sub G, force of gravitational attraction between the Sun and the Earth. So, let's call it sub SE. So, this is some number of newtons. And then in the next part, what is the force of gravity between the Sun and Mars? So SM. This is some number of newtons. All right, so this is more just, doing scientific notation in the calculator and also like how do we interpret this chart down here? Like what's going on here? So I will show you. So for the first part, force of gravitational attraction. So F sub G between the Sun and the Earth. All right, this is going to be equal to, well, here's our formula down here. You'll use this formula a lot. So big G, and then M1, we'll make that the mass of the Sun. M2, mass of the Earth. And the distance between them has got to be the radius of Earth's orbit around the Sun squared. So distance EO, radius of the Earth's orbit squared. Okay, so big G, 6.67 times 10 to the minus 11th. Boop. Times the mass of the Sun. So that is this number here. 1.99 times 10 to the 30th kilograms. So that's a lot. That is 1.99 million kilograms. It's a very big number. Times the mass of the Earth, which is a relatively tiny 5.97 times 10 to the 24th. So yeah, 5.97. Well, that's bigger than 1.99. But times 10 to the 24th, well, that's a millionth the size of times 10 to the 30th. So yeah, it's the time tens to part that really tells you how big the number is, not the number, the leading part of the number. And then we have to divide that by the radius of the Earth's orbit squared. So that is 1.50 times 10 to the 11th meters squared. All right, now I've just done a video where I showed you in some detail how to do all of the scientific notation thing. So I'm not going to go through it in great detail here. I'm not going to show you all the buttons. I'll talk you through the buttons. So 6.67. Then you need the EE function. So if that on that TI-84, first you hit the second button, then you hit the comma button, and that gets you EE. On my much cheaper TI-36X Pro, I have a dedicated EE button. So for me, it's just 6.67 EE minus 11 times 1.99 EE30 times 5.97 EE24. So that's my whole numerator. You can hit enter now or not. It doesn't actually matter. And then we have to divide this by 1.50 EE11. And don't forget that that number gets squared. So use the x squared button on the calculator. And if you do all that, so my calculator is telling me, I'll tell you exactly what it's showing me. It's showing me 3.52184893. And then it's the letter E, 22. So what does that actually mean? Well, let's just keep 3 sig figs since all of our other numbers are in 3 sig figs. And what you get is 3.52 E22. E22, well, that really means 3.52 times 10 to the 22nd. Now, I personally I'm not going to care if you write it as E22, but I predict you will have some science teachers in your academic career who will really care. So I recommend just get in the habit of writing times 10 to the 22nd. And what are the units of this thing? Well, this thing is a force. So the units will be newtons. So that's the force of gravity between the Sun and the Earth. So there you go. Similar thing, just for more practice. For part B, what's the force of gravity between the sun and Mars? So F sub g, sun, Mars, is equal to big G, mass of the sun, so that number, times the mass of Mars, which is this number. And all of this gets divided by the radius of Mars's orbit, d. Maybe I should have written r. But the radius of Mars's orbit squared. So this number down here. So when you're doing these things, I highly recommend one of your last steps should be write out on the paper exactly the numbers you're going to put into the calculator. So there's big G. Mass of the sun is still 1.99 times 10 to the 30th kilograms, times the mass of Mars, 6.42 times 10 to the 23rd, well, kilograms. I could have used it up there too. All right, I'm getting lazy. And then divided by the radius of Mars's orbit squared. So 2.28 times 10 to the 11th meters squared. So yeah, Mars is further away from the sun than the Earth. So notice that number is bigger than that number. So if we do all of this in the calculator, 6.67 EE minus 11 times 1.99 EE 30 times 6.42 EE 23 divided by 2.28 EE 11, and that gets squared on the bottom. We're only squaring that bottom part. So you hit the x squared button, and you end up with 1.639, so call it 1.64, a bunch of other stuff. The calculator says E21, but really best to write it as 1.64 times 10 to the 21st, and it would be newtons. So there's your answer for that part. So yeah, the forces are very big. Well, we were talking about, the sun pulling on planets, so massive things pulling on each other. So yeah, the forces are very big. Notice the force of the sun on Mars is much smaller. Well, Mars is smaller than the Earth. It's way less massive, and it's further away. So you end up with a much smaller force. So there you go. That's how you do it. Hopefully you found this helpful.